It's the height of a 50-story skyscraper, but its walls are full of air. It's made with 188,000 tons of concrete, but all you can see is plastic. It contains enough steel cable to build a suspension bridge, but no one will be driving across it. So what is it? It's a tent, the world's biggest tent. Imagine desert island beaches, Las Vegas entertainment, Turkish baths, a tropical paradise, just meters away from this. Welcome to Kazakhstan, and the second coldest capital city in the world.
Minus 35, 40 in the winter, plus 35, 40 in the summer. So it's very hostile.
To build this space-age pleasure dome, workers are battling some of the toughest conditions on the planet.
Technically, we were doing something in Astana that would be difficult to do in London. I mean, this is not easy construction. It's actually very challenging.
With work 2 years behind schedule, they can't afford any more delays.
It's a very, very significant project, and I think we may have got lulled into a false sense of security.
Will the world's biggest tent ever be finished? At a construction site in central Kazakhstan, the early shift is arriving for work. It's bitterly cold, minus 20 degrees Celsius. Despite throwing thousands of workers onto the project, construction of one of the world's most radical buildings is 2 years behind schedule. But one man is determined to get the job back on track. Engineering troubleshooter Selami Gürel works for the Turkish construction company Sembol. When the experts talk of impossible, Sembol calls in Gürel.
The pressure is just the time. Everybody wants his building, on time. But in these weather conditions, it's very, very difficult.
Even in a good year, winter in central Kazakhstan is bone-chilling, and this winter has been unusually extreme.
When the wind starts, you feel minus 55. It's very cold.
So cold that for many workers it's a fine line between life and a freezing death.
I remember one day they said someone is frozen up there. So the team went up and took him down. Such things happen.
The frozen worker survived. But Selami faces a far bigger problem than the cold. And that's Kazakhstan's president, Nursultan Nazarbayev. The president personally commissioned the building. He's tired of waiting for it, and has now demanded that it must be finished in time for his birthday, in just 18 weeks' time. And in Kazakhstan, when the president shouts, everybody jumps. The new building is part of the president's vision to transform his country. Kazakhstan is vast. At 2.7 million square kilometers, it's the 9th largest country in the world. It perches on the Great Steppe of Central Asia, an area of semi-desert. For centuries, nomadic tribes herded their cattle across these remote grasslands, living in portable homes, traditional tents called yurts. For 71 years, it was part of the Soviet Union. But with independence in 1991, this country began an extraordinary period of rapid development. The discovery of oil, vast amounts of it, gave Kazakhstan wealth. And the president knew just how he wanted to spend it. He decided to build a new capital at a remote spot in the middle of the country, Astana. He called in some of the world's leading architects and told them to jump. Out went the Soviet monoliths. In came extraordinary architectural fantasies that owed more to Las Vegas than to Moscow. New government ministries, a stadium, a concert hall, a glass pyramid of peace. Each year, a new architectural wonder, laid out on a master plan similar to Washington, D.C. Astana is now one of the fastest growing capitals in the world, and the people who move here are encouraged to feel close to their president. In the heart of the new city, at the top of the Bayterek Tower, newlywed couples can place their hands in a giant solid gold imprint of the president's hand and make a wish. But before you book your holiday to this extraordinary place, there's one thing you should know. Astana is the second coldest capital city in the world. Year-round, its average temperature is just 3 degrees Celsius. In winter, bitter winds sweep down from Siberia, plunging temperatures to 40 below. The city remains frozen for month after month. So the president realized there was one thing missing from his new glittering metropolis, and he had a vision.
Я хотел, чтобы было такое здание, где люди и зимой могли себя чувствовать как летом, чтобы здесь был пляж, место отдыха для детей, для взрослых, где одновременно могут отдыхать 10 тысяч человек.
A president with a radical idea needed a radical architect.
И стали мы выбирать и вышли на английского архитектора господина Нормана Фостера. И, естественно, я в новой столице хотел иметь уникальное здание, которых нигде нет.
If you want something unique, there are few better places to come than to Norman Foster's practice in London, where revolutionary architecture is the name of the game.
As we advance as a kind of evolution as designers, we are able to gradually stretch the boundaries.
Foster has pushed the boundaries again and again with iconic structures like France's Millau Viaduct, London's Gherkin, and the Hearst headquarters in New York. And when he was approached by the president of Kazakhstan, he saw an opportunity to return to a revolutionary idea he'd been thinking about for over 40 years.
Rectilinear farm and children.
In the 1960s, 70s and 80s, Foster collaborated with one of the 20th century's most brilliant minds. Richard Buckminster Fuller was an American architect who pioneered the idea of using geodesic domes to create vast self-contained environments, protected from harsh conditions outside.
Meeting with Bucky was extraordinary because he was somebody who had really devoted his life to the idea of dwellings that would be self-sufficient.
Dome-shaped biospheres act like giant greenhouses. By trapping the sun's heat, they can create a warm environment for everything inside. One of Bucky's most radical ideas was to cover 50 blocks of downtown New York with a dome.
The dome over Manhattan was a very evocative project, and it was really drawing attention to the potential for creating large-scale enclosures, creating microclimates, modifying a climate. Bucky was, and still is, a mentor in that sense.
Over 40 years after they first met, on the steppes of Kazakhstan, Foster saw the potential to realize his mentor's ideas on a massive scale and create an iconic engineering first for the president's new capital.
This was going to be a symbol, and ideally something that had not been done before.
To explore exactly what sort of structure would work best, Foster called in civil engineering company Buro Happel, where senior engineer Mike Cook is not quite so keen on domes.
A dome, well designed, should be in pure compression, and that's a pretty efficient way to use material, but it still has the threat of buckling.
A dome is a good way to cover a large space, but the weight on the roof pushes down on the supporting struts, compressing them. And that compression means the struts have to be thick and heavy, or else they buckle. Astana's remote location means that construction materials will have to be shipped long distances across Central Asia, so keeping weight to a minimum is essential. And it turns out there's an even lighter way to build a roof. In structures like suspension bridges, the cables carrying the load are in tension. Because they're being pulled instead of pushed, the cables can't buckle, so they can be very light. And if you transform a suspension bridge into a roof, you get a tent. A very big tent.
The clue's in the name, I suppose. Tent for tension. And tension is the most efficient way you can carry force in a material.
This is 5 times as efficient in terms of the ratio of the steel to the volume and the area enclosed.
So with that level of efficiency, Foster quickly settled on a tent. For his design team, led by Nigel Dancy, the challenge was to turn that simple idea into a thing of beauty.
Once we had the idea of doing something with the mast and having the mast as really a beacon, that was something that we really felt very strongly about.
Within weeks, they'd fleshed out a design for an iconic angled tent. Inside, they devised a vast leisure complex that would fulfill the president's dream to give his people a sheltered year-round entertainment paradise. Laid out on 6 floors. Inside an outer concrete ring, there's a vast car park on the ground floor. From there you can head up to 2 levels of Western shops, designer boutiques and a cinema. Rising above this are 2 floors of entertainments, a spa centre, restaurants, arcades, rides and a monorail. At the top, there's a tropical water park complete with a wave pool and 2 beaches. All this under the Buckminster Fuller-inspired energy-efficient tent. When it's freezing outside, it will be a pleasant summer's day in here. In December 2006, the president gave the design his approval and unveiled it to the world, naming it Hanshatir, which means the leaders or royal marquee, the crowning glory of his new capital at Astana. And despite its unique and complex design, he was told he would have it in just 1 year. Oh dear. Within days of the president officially approving the design, the diggers roll in. Construction of the world's biggest tent begins. Stage 1 is to build the foundations and the immense concrete ring that will anchor the tent into the ground. 195,000 cubic meters of soil are excavated. Concrete piles are sunk 10 stories deep into the earth. Construction crews cut, bend and wire together 9,000 kilometers of steel reinforcing rods. And a steady stream of lorries pour 188,000 tons of concrete into the foundations and lower floors. But this is a complex project on a vast scale, and it's soon apparent that the promise of building this structure in a single year really was mission impossible.
I don't think we quite understood what we let ourselves in for. It really is a very significant, big project. It's over 100,000 square meters in total area, and it's 145 meters tall. So it's a very, very significant project.
In November, the winter weather kicks in. As temperatures plunge, there's a danger that the concrete will freeze before it has a chance to set. So workers have to improvise using powerful burners to keep it warm as they mix it. Work slows to a snail's pace. Stage 1 is taking months longer than predicted, and matters are about to get a whole lot worse. The next stage is to build and erect the tent pole, a 2,000-ton steel structure that will rise 150 meters into the air. Unfortunately, it seems that no one can agree how they're going to do it. Time to bring in the troubleshooter, Salami Gurel.
First design of Foster and Partners was a vertical mast.
It was something that we thought about quite long and hard.
When something is vertical, I love it.
The single mast would be simpler.
I said, why don't we make it with a concrete chimney looking thing, you know?
Oh,
We can use slip form technologies, and I could finish it in 24 days, you know?
it wasn't something that we dismissed immediately, but it was something that was a very unusual thing to want to do.
It was too symmetrical.
Then I don't know why they tilted the heads.
In fact, the tilt is crucial to the design because the main buildings of Astana are lined up on a central axis. And the Han Shatir will mark one end of this axis.
The idea of tilting it started to address the fact that we wanted to create an entrance out the front, addressing that axes.
The Foster's final design called for the tent pole to be tilted at 15 degrees. A single tent pole would be unstable, so the engineers opted for a tripod.
Nice three-legged stool, stable.
Building it without any further delays was a challenge that Salami was determined to solve.
Being an engineer of 58 years old, I said I should do it.
The designers thought it could be slowly built up in sections, piece by piece, from the ground up using vast amounts of scaffolding. Salami came up with a much faster but highly unconventional alternative, starting with building the whole tripod flat on the ground.
He had the idea that he wanted to do everything on the ground, assemble everything, and then lift the whole tripod with its mast already attached up into the sky in one brave move. That is something we probably wouldn't have wanted to propose.
A major concern was that Salami's approach would require a vast crane, far bigger than anything available in remote Astana. Shipping one in would take months and cost a fortune. But never underestimate the troubleshooter.
Can you imagine you should rent a 800-ton crane in 30 trucks, load them, bring here in 2 months, bring them back in 2 months? So we said, let us make our own crane.
Of course, it will be no ordinary crane. Salami's plan is to use a brilliantly inventive combination of hinges, railway track, and some very high-tech winches. The tripod will be assembled horizontally, with 2 legs attached to giant hinges called pin joints, and 1 leg to a short stretch of track. Meanwhile, Salami's team will build a 60-meter tall tower, on top of which he will put his specialist winches, known as strand jacks. The jacks will pull up the tripod on its hinges, with the 3rd leg sliding down the track into its final position. It's never been done before, and no one knows if it will work.
My mission is to fulfill, to satisfy Foster and Partners, just to do it.
With another winter approaching, Salami's steel team must work fast. Specialist welders cut and weld 2,000 tons of steel tubing, shipped in from Turkey, into 3 giant legs. On top of the legs, they're building a giant ring, 20 meters in diameter. This will support the cables that hold up the roof. And on top of the tripod is the giant mast. The whole structure is 150 meters long, equivalent to a 50-story building lying on its side. Now the challenge is to pull it into the air.
Concentrating all of the energy into that big event means that big event concentrates all the risk.
There's a very real danger of a catastrophic failure that would set the project back by months. And that wouldn't go down well with the president. To lift the tower, 16 strand jacks will grip the cables and pull up the giant tripod 50 centimeters at a time. Inside each strand jack, an upper chuck tightens to grip the cable. A lower chuck releases its grip, and a hydraulic piston pushes upwards lifting the tripod. Next, the lower chuck tightens, the upper chuck releases, and the piston retracts. The whole process is then repeated time after time. To make sure the load is evenly distributed, all the strand jacks must work in perfect synchronization. As the day of the lift dawns, Salami's plan swings into action. At the top of the lifting tower sit his secret weapons. The hydraulic strand jacks have been brought in from Switzerland. They're costing $1 million to rent, so Salami's plan had better work.
Initially, everything was sitting on supports, you know. But once you start pulling, all the forces should come to those pin joints, you know. Well, the pin joint has a base plate which is sitting on concrete foundation.
The concrete has to withstand forces of up to 2,500 tons.
Very, very big forces. So there's always that danger that someone missed something. You know, some bolt gets overstressed.
As the lift begins, it's a critical moment. Can the cables take the load of the tripod?
We just lifted up. There were 1,500-ton horizontal forces coming there. Nothing happened, you know. We were just airborne.
To stop the tower falling over as it begins to raise the tripod, cables anchor it to the concrete rim of the building. Little by little, the strand jacks inch the tripod ever higher. Over the next 48 hours, it rises majestically into place. When the whole tripod is in position, the third leg is welded to its base. The moment of truth arrives. Will the structure stand up when they release all the wires?
The president of Kazakhstan was here that day. Then we released the crane, you know, very exciting, heart beating, you know. The load was transferred from the mobile crane to the structure.
It was a great piece of showmanship to have that event.
But we did it.
By ignoring the conventional way of doing things, Salami has saved hundreds of thousands of dollars. And he's got the tripod safely erected before another extreme winter sets in. But by the spring, the project is 16 months behind schedule, with some major challenges still to come. A new team of workers has arrived on site. The task facing these specialist engineering climbers is the most dangerous part of the whole project. Installing the high-tension cobweb of cables that will support the outer skin of the world's biggest tent.
It's unfair to call it a tent, really. You know, it is a precisely engineered tension structure.
Whatever you call it, it needs a roof. Once again, the responsibility of making sure work progresses as quickly as possible falls to Salami Gurel.
We had bundles of cables, 38 millimeter in diameter. The longest was about 140, 120 meter long, shortest around 95 meter long on the backside.
The cables that will support the lightweight roof each weigh up to 2.5 tons and have to be pulled up in pairs.
While pulling them, there was a task to connect the blocks that connect the double cable, make it as a pair, at every 70 centimeters, you know.
Getting everything exactly right is time-consuming.
Considering 190 pairs, if we can make one pair daily, then we need 190 days, and we didn't have so much time.
Clearly, relying on a single team of expert climbers was going to put the project many more months behind schedule.
We should increase the number of the teams, plus the number of the lifting cable pulling devices.
So Salami brings in nearly 300 extra workers, adding another 9 teams, and equips them with winches stripped out of old Russian cranes. It's risky work for old equipment and inexperienced climbers, but the job instantly picks up speed.
We have done, let's say, 10 pairs every day. So we have done it within almost 20 days.
Salami's calculated risk pays off. The net of cables is quickly completed and the next crucial stage can get started: tensioning. To cope with the weight of snow that will fall in winter, the whole roof needs to be able to move just the right amount.
Early on in the project, we made this model, really simple model. There is either wind during the snowfall or after the snowfall, and that's going to build a heavy deposit of snow on one side, and that causes this deformation. But if you allow this rocking to occur or some movement at the top, it actually helps reduce the buildup of stress on this side.
Instead of a moving mast, Mike Cook has devised this moving hub. The hub is enormous, 17 meters tall and 20 in diameter. But despite its huge size and weight, in high winds or heavy snow loads, it can move 30 centimeters from side to side. A palm sweating 75 meters above the floor of the Han Shatir, Salami's assistant is inspecting the 12 pillars on which the hub rests. Astonishingly, these upper pillars aren't actually fixed to the tripod below. They simply rest on bearings. If you could pull them hard enough, they would come apart. Luckily, the 1,000-ton load of the roof holds them down. To make sure the hub doesn't move more than 30 centimeters, the entire cable net must be stretched to just the right tension. That's the job of Alex Luca and his tensioning team. Working their way around the structure, they attach the ends of each pair of cables to 2 hydraulic rams. When Alex turns on the hydraulic pump, the rams push on a plate that pulls the cables tight. The nuts are then tightened and the process repeated on the next set of cables. The cables on the Han Shatir are tightened to an unusually high level, 80% of their maximum load. The wires will be as taut as the cables on a suspension bridge. With the cable net complete, the stunning shape of the Han Shatir takes its place on the Astana skyline. Inside, thanks to a temporary plastic roof, work on the interior can finally get started. Everyone's racing to play catch-up before the president's patience runs out. In Germany, a team of designers from Vector Foiltech has spent over a year designing the roof of the world's biggest tent. It will consist of 836 transparent plastic cushions. To make life extra difficult, every other cushion is a different shape, and each one has to fit precisely. It's a 20,000 square meter three-dimensional jigsaw puzzle. It looks good on the computer screens, but for Vector Foiltech, the key to success is installing the cushions in warm weather, and it would be complete madness to install their roof through an extremely cold winter. Their man in Astana, with the job of putting the jigsaw together, is Matt Wilson, an expert climber who specializes in rope access engineering.
So the containers are shipped from Beijing. Basically, Beijing fit it with this very temporary shelving to sit the cushions on. The cushions are unique to a single location on the building, and they're folded in a particular way so that they're basically ready for when they're hung up onto the structure.
The roof cushions are made up of thin sheets of a material called ethylene tetrafluoroethylene, or ETFE for short. 3 sheets of ETFE are joined together, one on top of another, to form each cushion. Air will be blown into these to form a lightweight rigid pillow. This is the wonder material that makes Buckminster Fuller's dream of insulated biospheres possible. It's 100 times lighter than glass. Its surface, like Teflon, is non-stick, so it doesn't need cleaning. And ETFE is tough. When it's warm, it stretches and can comfortably take the weight of 5 men. It won't catch fire, and it can be cut into any shape required. But one thing ETFE doesn't like is being installed in the cold. Despite this, Matt Wilson has been instructed to waste no time replacing the temporary plastic sheets with the ETFE cushions. Originally, the cushions were going to be installed in summer, but with construction so far behind schedule, Matt's team of climbers has been working through the winter.
Generally, we would fit the 2 short sides first, working from the top down, which usually provides very little problem because the cushions have a great deal of distance to stretch. The material becomes less elastic in the cold weather, which means when we stretch the cushions into the aluminium frame, we have to basically give them more time. So in summer, where something might take sort of 10 to 15 minutes, through winter we may take sort of 2 or 3 hours.
Through an extreme winter, even by local standards, Matt has been under constant pressure from Salami Gurel.
We have our German subcontractors teams who are not used to working in minus 30, minus 20, minus 15.
The days that are really difficult is when the ambient temperature is very cold and the wind is high.
We bought good clothes to the for the workers.
The cold is extreme at times.
Blankets, some heating units.
Minus 37, and that's not with wind chill. That was an ambient temperature. The wind chill was it was off the scale on the meter that was reading it, and most of the time then we're not able to work at all.
For Salami, Matt's team was working far too slow. He had to find a way to get the roof finished more quickly.
So what we said, let us also put our teams on top of this net.
The troubleshooter invoked the Gurel theorem. Throw loads of people at the job and get it done fast.
In order to avoid any accident, we have decided to install a safety net inside the radial cables so that people can walk on it.
Next, the experienced climbers trained the new workers to install the cushions.
We have brought here our own teams, which is 400 people.
They've been brought in to speed up the work. That gets frustrating, if not a bit disconcerting.
10 teams, 83 cushions per team.
And the team starting competing with each other, you know?
It's the worst safety you've seen on the planet.
Despite Matt's concerns, the teams press on.
So this has to come down much further. Yeah. Into the hooked profile on the alloy here.
Sometimes, Matt can hardly bear to watch.
They rip a lot of the edges, and then the work I'm doing in terms of calculating things at the moment is calculating a repair schedule.
By spring, the cushions are in place, but Matt still fears the worst, because now he must inflate the roof for the first time. And it seems inevitable that installing the ETFE in freezing cold will have damaged the cushions and caused dozens of leaks.
Now we're ready to turn the supply on for the roof for the first time.
Every cushion is attached to an air supply. A computer-controlled pumping system pumps air at low pressure round the whole tent. The fans blow in 60,000 cubic meters of air, equivalent to a large airship. It takes about 7 hours to inflate the roof. For the roof to look as the architects intended, all the cushions must evenly inflate to a height of exactly 70 centimeters. Matt is prepared for the worst, but he can't quite believe what he sees.
Well, the first inflation looks like it's gone okay. The cushions have good pressure, and there's even distribution of air pressure throughout all the cushions. So yeah, we're looking pretty happy with it.
Against all odds, the winter installation has been a success. Once again, Salami's boldness has saved valuable months. And it's up. The world's biggest tent, a structure unlike anything else on Earth. But inside the tent, no one has time to celebrate. It's now just 6 weeks until the president's birthday and the grand opening. Across 6 floors, a small city is under construction. Dozens of painters are applying 13,000 litres of white paint. Electricians are wiring up 17,000 lights. And teams of carpenters are frantically fitting out shops and restaurants. Six weeks later, the interior is nearly complete. It's the day before the grand opening. These teams of workers have almost completely transformed the Han Shatir from a building site into a 21st century pleasure palace. Thanks to the ETFE roof, the Han Shatir's plant life is in stark contrast to the dusty steppes outside. Hundreds of plants from all over the world will thrive in this giant greenhouse. The structure is crammed full of every imaginable entertainment. The tropical beaches and water park, Turkish baths, saunas, a gym and spa, a cinema and 2 floors of rides and arcade games. Top-name brands from around the world have bought into the concept. They all want a presence inside the world's biggest tent. And now hundreds of workers are in a race to get the goods into the stores in time for the opening. The design team from Foster's and Bureau Happold has flown in from London to see the finished building for the first time.
I should have brought my swimming trunks.
The water park on the top floor is enclosed within its own ETFE roof. Over 1,000 kilometers from the sea, the people of Astana now have their own year-round beach.
Quality of light, it is like being on the beach. What more could you want?
While the water park is maintained at tropical temperatures, the rest of the interior is maintained as a pleasant temperate zone all year round, thanks to some very clever design and engineering work. To fulfill Buckminster Fuller's dream of an environmentally efficient dome, the designers needed to harness nature to do a lot of the heating and cooling. In summer, with temperatures outside hitting 35 degrees Celsius, the challenge is keeping the building cool. To stop it becoming a giant greenhouse, the ETFE on the roof is covered in hundreds of thousands of silver dots. This fritting, as it's called, reflects some of the sun's heat. But the building also uses a natural process called the stack effect.
It's the same as you have a chimney, a fireplace at home. You know, you get hot air and it's going to get sucked out.
At the top of the tent, above the ring, adjustable slats allow warm air to be released.
We've got openings all the way around the crown of the very top of the tent. When the wind is blowing and it's cooler, as it passes through, it's going to suck the hot air through.
Inside the building, hot air, which is lighter than cold, rises naturally to the top of the tent. At this height, the wind outside blows faster than at ground level. It creates suction, drawing the hot air out. To replace it, chilled air is created at ground level. Air is drawn in through intakes around the building, cooled and blown out through vents and nozzles inside.
We're not trying to condition the entire volume, but just the occupied spaces.
So even in the hottest days of summer, it's pleasant inside. But what will happen when it's -40 outside? In winter, the roof will act like a giant transparent duvet. insulating the interior from the cold Siberian winds and allowing in heat from the sun.
You're always going to get a lot of solar radiation irrespective of the time of the year. In that respect, the enclosure, the volume and the material actually helps to trap heat.
Even in the tropical pool area, which is kept at a constant 30 degrees Celsius, no energy is wasted.
The excess heat that is generated in this area all year round can be recycled, and mainly in the winter is used to heat up the car park levels down at the bottom at +5 degrees, so you'll never be frozen.
The transformation is complete. From concrete shell into leisure paradise. Everything is ready for the big day. But before the president will allow the building to be opened, he has insisted on a personal tour of inspection. And he's on his way. On the morning before their president's 70th birthday, the people of Astana stream towards the Han Shatir, 140,000 of them. But before the world's biggest tent is open to the public, it must pass its presidential inspection. It's a nervous time for all involved. What will he think of the latest addition to his capital city?
Я с самого нуля своими руками все это чертил. Я каждый месяц приходил сюда, по ходу строительства все смотрел, исправлял что-то. Я ждал этого момента. Я очень рад, что я вижу, что наконец объект завершен.
So the president is happy. And the doors are thrown open to the people of Kazakhstan. Their reaction will be the best indication of whether this amazing structure will be a success. The vast roof inspires wonder. In the food court, young Kazakhs are quick to get their teeth into international cuisine. Some have never seen the beach before. London, Paris and Milan have arrived in Kazakhstan. And there's no doubt that the amusements are a hit.
Мне понравилось, что такое необычное здание, во-первых. Также мне понравилось то, что приятное место, тепло, уютно. Мне кажется, здесь народ всегда будет гулять. Ну, в общем, народу много будет.
Бұл біздің еліміздің бір символдарының біреуі болады деп ойлаймын.
To celebrate the opening of his new building, the president lays on a spectacular opening ceremony. Ancient culture celebrates modern architecture as horse riders, hunters and acrobats pay tribute to the thousands of workers who built the Han Shatir. Standing out from other buildings like a beacon in the wilderness, the Han Shatir is not just another shopping mall or amusement arcade. It's an iconic building, a statement of the president's determination that Kazakhstan will be a leading player in the modern world.
This is the symbol of Kazakhstan and Astana, let's say. This is a symbol for Astana.
As an engineering achievement, this is the first step in a new direction, paving the way to low-energy habitats and even cities of the future.